everyone. So I had some requests of people asking to have some examples done on packet 4 for unit 3. So today we're going to look at some problems on page 6, 2 on page 7, and a few on page 9 together, okay? So hopefully these examples will help you move through all of the work. If you need more, please feel free to send me an email and I can try to help you out there. So let's look at problem number 5 first. The directions here say, if the sides of a triangle have the given lengths, find a range of possible x values. Since you do not know which two sides are the shortest, you must account for all possibilities. So remember at the beginning of this section, they talked about, like, if you have a triangle, let's say the side is 3, the side is 2, and the side is 5, your two smallest sides must add up to be greater than your largest side. If it is greater than your largest side, then it's a triangle. If it's not, then it can't be a triangle. So since we're given expressions here, like AB is 4x plus 25, then we have 3x minus 2, and then 9x minus 5, we don't actually have number values. We do not know which sides are the smallest, so we can't add them up. Therefore, we have to then use, not guess and check, but we have to use all combinations and possibilities to see what that gets us. So I start off by drawing a figure, triangle ABC, and I labeled it as such because I know that there are 2 points AB and a third point C in this triangle, so ABC. Well, side AB is 4x plus 25, side BC is 3x minus 2, and side AC is 9x minus 5, right? So let's just say I take a random combination. Let's say I say AB plus BC has to be greater than AC, right? So in theory, all I'm saying, AB plus BC has to be greater than AC. Okay, well, since I know these values, I can actually plug in these values. So if AB is 4x plus 25 and BC is 3x minus 2 is greater than AC, which is 9x minus 5. Let's combine like terms. So 4x plus 3x is 7x. 25 minus 2 is 23, is greater than 9x minus 5. I'll subtract 7x from both sides. I end up with 23 is greater than 2x minus 5. Add 5 to both sides. We get 28 is greater than 2x. Divide both sides by 2, and we get x is less than 14. Additionally, you can also write this as x is less than 14 this way. Just make sure that the point, right, is pointing towards the x. So you don't want to flip the sign because you didn't divide by a negative or multiply by a negative. Okay, so that's one value there. We got one range value. Now we have to try another combination. So last time I did AB plus BC. This time I'm going to do let's use pink. AB plus AC equals BC. So again, I'm going to write the skeleton of it here. Oh my God, it's not a pen. So AB plus AC is greater than 3x minus 2. So AB's value again was 4x plus 25 plus AC's value, which was 9x minus 5, is greater than 3x minus 2. Combine your like terms. 13x plus 20 is greater than 3x minus 2. Subtract 3x from both sides. We get 10x plus 20 is greater than negative 2. Subtract 20 on both sides, and we get 10x is greater than negative 22. Divide by 10. Again, I'm dividing by positive 10, so I don't have to flip the sign. X is greater than negative 2.2. So that is my second range value. I'm going to tell you a hint. Once we have all our range values, we're not going to use all 3. We're actually only going to use 2, and we'll talk about which 2 make the most sense. So, great. So now I had this combination done, right? my last combination to do is AC plus BC is greater than AD. So I'm going to write that down again. Oh my gosh, I keep messing up my pens. AC plus BC is greater than AB. So AC is 9x minus 5 plus 3x minus 2 is greater than 4x plus 25. Combine like terms, we have 12x minus 31. Is that 31? Negative, no, it's not. What am I doing? Negative 27 minus 5. Oh, it's not 27. I'm sorry. It's 2. God, I need to wake up. So 12x minus 7, my bad, is greater than 4x plus 25. Subtract 4x on both sides. Get 8x minus 7 is greater than 25. Add 7 to both sides. We get 8x is greater than 32. And x equal, or not equal, sorry, is greater than 4. Okay. Now, of the 3 ranges that we have now calculated, we obviously cannot use all of them because when we have a range answer, remember, we only use 2 values. X would be in the middle, and we would have to figure out what number would be here and what number would be here. This would be the max number, and this would be the minimum number. All right, well, let's look at what these numbers actually mean, right? So if I had a number line here and I told myself, well, 14 is the largest, so x has to be less than 14, right? So I'm going this way. It has to be less than 14. Then I'm hit with another value that says x has to be greater than negative 2.2. So this here is negative 2.2. So it's greater than negative 2.2. But I also have another stipulation that says x has to be greater than 4. Okay, well, if x has to be greater than 4, this value here, everything from negative 2.2 up until 4, cannot be used. Therefore, I cannot use this value. It's an extraneous answer. So my setup, my range here would be x is less than 14 and x is greater than 4. And if you wanted to, you could check any number within this range and plug it in for x, and you would find that it would fulfill that triangle theorem where all the sides, or the 2 smallest sides, have to be larger than the largest side. Okay, so that is 5. It's not super complicated, it's just new. 6 is very similar, so you can go ahead and handle that. Looking on the next page, I'm going to now start problem number 8. The directions here, or sorry, the problem in itself says, list the sides of triangle JKL in order from least to greatest. So first of all, I'm just going to draw my visual. I won't even read the whole thing. JKL. Okay. If the measure of angle J here is 2x plus 6 degrees, the measure of angle K is 10x minus 11 degrees, and the measure of angle L is 3x minus 10 degrees. Again, we have to list the sides in order, right? Well, I don't know the number values of each of these angles because I don't know x. So what would be the best way to solve for the angle sides? Yeah, it would be first to solve for x. Now, we know this because you guys see we're pointing inside, right? Each one of these is angles inside the triangle. So when I'm dealing with angles, I know that I can add them all up and equal it to 180. So 10x minus 11 plus 3x minus 10 plus 2x plus 6 equals 180 degrees. Now, combine your like terms. I know some of you still need colors for this, and that's fine. We have 3x, 10x, and 2x, which all combine to make 15x. And then be careful of your signs here. We have negative 11, negative 10, and positive 6, which gives us negative 15. Okay, all equaling 180 degrees. Let's add 15 to both sides. We get 15x equals 195 and x equals 13. Now I have to take that 13, and as we know by now at this point, you got to plug it back in to your values. So I can just do that right here because I have the space, but you can do yours wherever you need to. 10 times 13 minus 11 is 119. 3 times 13 minus 10, this was L, ooh, I don't know why I put that parentheses there, is 29. So this is 29, this is 109. And then 2 times 13 plus 6 is going to equal 32 degrees. Now we can go back to the question and actually answer what they were asking us for. So they had list the sides, right? Sides in order from least to greatest. And if you remember from the beginning of this topic, the opposite sides of the angles correspond to the side lengths, right? So my since we're starting with the least, the smallest angle is 29. So what side is opposite? It would be JK. Then my next largest side is 32. What's opposite 32? That would be KL. And then lastly, oh, I would use purple. Let's use pink. My largest side is 119, and what's opposite 119? That would be segment JL. And that is your final answer. You're really starting to put together everything we've learned so far. So it's really important that as we move forward, you understand what is being asked of you. I'm actually not going to do problem number 9. I just will leave it at 8. However, on page 9, so I'm going to skip page 8. 8 is just more review. On page 9, I'm going to do problem 7. Okay. This time in problem 7, it's asking us to list the angles of this triangle in order from least to greatest. So I'm first of all going to draw my triangle. If you don't know what type of triangle it is, you just go with equilateral. So A, B, C, and from least to greatest. If AB, this is a side, AB is 6x minus 35. BC is 4x plus 11, and AC is x plus 29, and the perimeter of ABC is 192. Perimeter is kind of like, well, I mean, it's not kind of like, it is the entire length around the figure, right? In this case, it's just the triangle. So I know that this plus this plus this is going to equal 192. So I'll set up my equation like that. 192 equals 4x plus 11 plus 6x minus 35 plus x plus 29. Find your like terms. That gives us 11x plus, again, find all your constants. Be careful with the addition with this because there is a negative value in there. 11x plus 5 equals 192. Subtract 5 from both sides, we get 187 equals 11x. Divide by 11 on both sides, and x equals 17. Now, obviously at this point, we take that 17 and we plug it in. So 4 times 17 plus 11 equals 79. 17 plus 29 equals 46. And 6 times 17 minus 35 equals 67. Now again, the question here is asking us for our angles, right? But if we have the side lengths, we can determine which angles are correspondingly larger or smaller based off of their opposite side. So since we're going from least to greatest, let's start from our smallest number. Our smallest number is 46. That is side AC. The angle opposite that is angle B. The next smallest side is 67, which is side AB. The angle opposite that is angle C. And then last but not least, our largest side is side 79, which is BC, and that is opposite angle A. So that is my final answer for my angles put in order from least to greatest. I hope that helped. I think that you guys have enough examples to finish off the rest of the problems. If you are getting stuck, please, please, please make sure you come see me during class. I know some of you, it helps to do problems together rather than just listening to a video, but please take control of that and ownership of your learning. But I will see you when I see you. Bye.